Dah.
Okay, intro sekali intro.
Ya, aku ya.
Ah.
Okay, Assalamualaikum warahmatullahi wabarakatuh. We from project 4. Want to present our project. Okay. Our group member is Muhammad bin Ahmad Danial, Muhammad FAIQ bin Ahmad SANI, HUZAIFAH bin Ahmad AZMI, Muhammad Ashraf bin ISMAIL, Muhammad IQBAL bin ROHIM. Next. Okay, for question 1, the northwest corner rule is a method adopted to complete the initial feasible solution of the problem. Okay, the name northwest corner is given to the method because the basic variable are selected from the extreme left corner. The prescribed condition for solving the problem is that demand should be equal to the supply. In case the demand is more than supply, then the origin is added to the table. Next is the supply of dummy origin will be equal to the difference between the total supply and total demand. The cost associated with the dummy origin will be 0. Last one is similarly in the case of the supply is more than the demand, the dummy source is created whose demand will be equivalent to the difference between supply and demand. Again, the cost associated with the dummy source will be 0. Okay, for the calculation, first we use northwest method, northwest corner method, then optimal solution. Okay, for the first one is we create the table first, then we fill the calculation. We fill the information in the table. Next, move the solution in the next we total up all the calculation, then we get the total transportation cost, which is 922. Then put into formula which is m plus n minus 1, which is 4 plus 5 minus 8 equal to 8. So the total number of the allocated cell is 8. Therefore, since the allocated number is equal with m plus n minus 1, the solution is okay. Next.
Okay, for stepping stone method, which is stepping stone method is used to get the of the initial feasible solution of any method, use cost method or forget approximation. Hello. Okay, for the optimal solution, we use our group use stepping stone method. Okay, stepping stone method is used to check the optimality of the initial feasible solution determined by using of any method, which is northwest method, least cost method, or Vogel approximation method. Thus, the stepping stone method is a procedure for finding the potential of any non-basic variable, which is the empty cell, in terms of the objective function. Okay. There are a series of steps that are involved in checking the optimality by using the step stepping stone method. Okay, first in a closed loop, select in a sequence such that one cell is unused or unoccupied, and in and all other cells are used or occupied. A pair of conservative use cell lies either in the same row or the same column. Once the loop is created, assign plus or negative sign alternatively on each corner cell of the loop, but begin the plus sign for the unoccupied cell. Repeat, which is for example, uh, positive minus plus minus until the path is meet at the uh, unoccupied cell. Okay, repeat the step until all the unoccupied cells get evaluated. Now, if all the changes are positive or equal or greater than zero, then the optimal solution has been reached. Okay, for the this is the optimal this is the optimal solution of the glucose transportation problem. Next, this the other step. For example, the category 3 warehouse 3 we got the negative. So we need to find another ways to until it positive. Next. Next. So that's all for the optimal solution. The way or the the work how to do the optimal solution. So that's all from question 1. So we proceed to question 2. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Umar. So I will go through question 2. Okay, so this question is regarding PDM. So PDM is a scheduling technique of the sequences activity process. The precedence diagramming method or PDM can be used for creating a project schedule network diagram, which is an output of this process that is used as an input for the developed schedule process. Some activities might require predecessor or successor activities to be completed or started before they can be started or completed themselves. Next, the method involves the identification and visualization of the sequence and dependencies of activities in a project or a part of a project, such as a work stream or a work package. And finally, regarding critical path. So critical path is a logically structured project schedule network diagram, specifies a sequence of activities that need the utmost attention of the project team. Thus, this sequence of activities is the critical path. It is the longest path in a project schedule network diagram. So as we can see in this PDM, so basically the letters or alphabet A, B, C, D, E, so on and so forth is the activity code for the question. So what we need to find is the ES, which is the estimate start, the EF, the estimate finish, LS, the last start, and LF, the last finish. In order to find the estimate finish, okay, so first thing first that we need to do to see the progress is we need to find the estimate finish. So to find the estimate finish, we need to create the estimate start plus with the time. The time is given in each of the activity code. Then we get 44 days. Then next step, we go rewind from the finish to the start to find DLS and DLF. So the formula to get the LS, which is last start, is by subtracting last finish with the time. So we will get an equal of 0 if we go rewind from finish to start. So what we need to find in this question, beside ES, EF, LS, and LF, is the critical path. So as stated earlier, the critical path is the longest, like we can see, the longest path. So the longest path that can be found is A to the B to the C to the E to the F to the J to the L, and lastly to the N, which amounted of 44 days. This like this: A, B, C, E, F, J, L, N, the critical path. So that's all from me for question 2. Okay, next presenter.
Okay, for the question 3, linear programming is a mathematical method for optimizing operations given restrictions. Linear programming's basic goal is to maximize or minimize a numerical value. So it consists of linear functions that are limited by linear equations or inequalities. A prominent technique for discovering the most effective use resources is linear programming. And it also has linear functions that are subjected to the constraints in the form of linear equations or in the form of linear inequalities. Equalities or inequalities can be used as restraints. For profit and loss calculations are part of the optimization challenges. And it also used for analyzing various inequalities in a scenario and estimating the best value that can be obtained under given constraints. Okay, next.
So next is for calculation. First, let number of toys of type A be X, number of toys type B be Y. So first thing, we should do a table and fill first item, number, machine, and profit. So in item, we have type A, type B, max, available, time. In number, we have X and Y. In machine, we have three machine. First machine is 20 minutes, 6 min, 6 hours, 6 divide 60 min equal, so time is 360 min. So we go for machine 2. Time required on type A is 18 min, type B is 0 min. Maximum available time 360 minutes, and we can see calculate the 18x plus 0y equal less 360. So x equal less 20. Machine 3, time required on type A equal 6 minutes, type B equal 9 minutes, maximum available time 360 minutes, and calculation 6
x plus 9y equals 360 and 2x plus 3y equals 120. Next. So next is maximize the profit. Profit on type A is RM 7 and 50 cent. Profit on type B is RM 5. So we use the Z equal 7.50x plus 5y. Combining all constraints makes Z equal 7.50x plus 7y. Subject to constraint 2x plus y equals 60. X equals 20. 2x plus 3y equals 120. So x equal more 0, y equal more 0. Next.
Okay, to get for maximum profit, we can do with graph. Okay, that we get from latest answer is 2x plus y less than 60. Okay, for the graph, x we can put 10, 20, 30, 40, 50, and 60. And for the y is same as x, 10, 20, 30, 40, 50, and 60. Okay, then we can put for corner points for A, 0, 0 for x, and y 40. And the B is 15, 30. C is 20, 20, and for the D is 20, 0. Then we get, we put half x less than 20. So for the value of z is, for A is 200, for B is 262.50, C 250, and D 150. So we can get the number of type A toys equal 15, number of type B toys 13, and we can get the maximum profit 262.50 cent. Okay, next. Okay, just that from us. Thank you so much.